Good evening. Go ahead and take out that study guide. Last video for Unit 2, Coordinate Geometry, Parallel and Perpendicular Lines. Going to kind of give you a glimpse of what we're going to be practicing tomorrow. Should be a real quick presentation for you. First off, think about what you already know about parallel and perpendicular lines. Think about the notation. Think about a picture of what it would look like. Okay? We know that parallel lines are coplanar lines that do not intersect. Okay? Thinking coplanar versus non-coplanar lines that don't intersect, that's your skew lines. Okay? Parallel, strictly coplanar. A picture, what would that look like? Remember geometric notation in the diagram, the arrows, set of 1 or set of 2. And if we were to name these lines A and B, our notation would be that A is parallel to B. This is what we have done so far in talking about parallel lines, not mentioning any transversal, just the parallel. Let's move on to perpendicular. Here we have two coplanar lines, notice the specificity there, that intersect at a 90-degree angle. And be very careful. I want you to make sure you write all of that because I've noticed a couple of students, just a handful now and then, they won't include this bottom part. They will simply say it's two coplanar lines that intersect. And I'm here to tell you that is not enough. I want us to be specific with our definitions. We know perpendicular must contain a 90-degree angle. Okay, go back and reference your dictionary if you need to. Go ahead and draw that diagram. What would that look like? Notation. Seeing that box in the diagram, let's label this C and D, line C and D. Our notation would be simply that C is perpendicular to D. So that's what we know so far about parallel and perpendicular. Let's make the bridge. Let's ask the question, how would we work these types of lines on the coordinate grid? How would we identify them? How would we graph them? Okay, what would we need to know is true about parallel lines on a coordinate plane, about perpendicular lines on a coordinate plane? Well, I think one key thing has to come to our minds, and that is slope. We talked about it on our block day, but think about slope in the context of parallel lines. If it's coplanar lines that do not intersect, think about your rate of change. It must be constant. It must be the same for parallel lines. Let's think about perpendicular. Perpendicular, I see a negative slope and a positive slope, so opposite signs there. And I also see that as they're traveling away, if they're truly traveling away at 90 degrees, wouldn't their rise and runs be flip-flopped? Okay? Wouldn't their rise and runs be flip-flopped? So we need to say opposite sign, and we need to say reciprocal rise over run. One way to check if you have opposite signs and reciprocal rise over runs is if the product of the slopes is -1. That's going to be the test as to whether or not you have met both of these conditions. Okay? Let's get some practice. Let's see how we could apply this. First example. Given the set of equations, graphs, and descriptions below, how many of these lines would be parallel? Focus on slope. Focus only on slope here. Starting off with this first equation, slope-intercept form, we see that the slope value given is 4. Sliding down, this is standard form. We don't know, we can't visually see what that slope value is right now, Let's go find it. Think about our last video. We practiced this, and then we continue to practice it in class. Divide by that coefficient, -5. And we have y equals, the negatives cancel, 4x minus 3. Now that we have slope-intercept compared to slope-intercept, what do you notice about the slope value? Pull that slope out. I see that's a +4. Next up, the line that contains those 2 points. If we have 2 points, can we find a slope value? Yes, we can. Label if you need to, x1, y1, x2, y2. We know that slope formula. Go ahead and plug those numbers in. Be careful when you simplify. Watch out for those negatives. Okay, negatives cancel, and we end up with a +4 slope value. Okay, think about how those compares to what we have found so far. Last but not least, analyze the graph focusing on slope. We found slope. We found slope. All of this was to find slope. So now we need to pull the slope from the graph, then we can compare them all. I see 2 dots, one there and one here. Let's do our rise over run. 1, 2, 3, 4 down is -4. Traveling 1 to the right, +1. That makes our slope value -4. Compare the slopes that we have found and think about parallel slopes being the same slope from the last screen. I think we can conclude that this line is parallel to this line, is parallel to this line. So we have 3 parallel lines that all produce the same slope or equal slope of 4 in this problem. The only one that we had to knock out was the graph here, did not have an equal slope. Final example. Let's go ahead and read through this. Given the set of equations, graphs, and descriptions below, which 2, notice the specific nature of the question now, which 2 of these lines would be perpendicular? So now, think back to what we said about perpendicular. We said opposite sides, and we said reciprocal. So we're looking for those 2 things to identify perpendicular. Well, here we go. First equation, slope-intercept. They give us the slope value of 1/2. Let's hold on to that. Next up, convert your standard form to slope-intercept. You'll notice that every time I solve for slope-intercept, I do it the same exact way. Now that I'm in slope-intercept, identify where that slope value is. Okay, let's keep moving here. The line that contains the points 4, 9, and 0, 3. Well, let's see here. Based on our formula, y2 minus y1 over x2 minus x1. And if you need to, label those points again. Let's make sure we get them in the right place. Go ahead and simplify. We have found 3 of the 4 of our slopes at this point. Let's delve into the graph, see what our slope is. Identify 2 points on that graph. Travel your rise over run. Down 2, +1. That makes our m value -2. At this point, These four values are the slopes that we're looking at, and we're looking for opposite signs and reciprocal flipped fraction values when compared to each other. Well, let's compare these two. Opposite signs, that is true, but are they reciprocals of each other? No. So these two are not perpendicular. Let's compare the 1/2 to the 3. Are 1/2 and 3 going to meet both of these criteria? Well, it doesn't meet either one. Let's take a look at the 1/2 and the graph. Well, I see positive, negative. We know that every integer value is a fraction over 1. So is this slope the reciprocal of the graph slope? I think we found our pair here. But let's explore the other options. Is this opposite and reciprocal to the 3? No. Is this opposite and reciprocal to the -2? No. And is our positive 3 opposite and reciprocal to the graph -2? No. So the only connection, the only two slopes that met both criteria, they were opposite signs. The 1/2 is positive, the 2 is negative. They are reciprocal fractions of each other. Positive 1/2, 2 over 1. Right? Those are the only two equations that are perpendicular. If you have any questions about parallel or perpendicular at this point, specifically focusing on slope, go ahead and jot those down. Your teacher wants to hear from you tomorrow. Have a nice night.